type, so struct a new node, that is something that I could do this notation on. A new node dot n gets 1, 2, 3, and then a new node dot next gets null. But I didn't do that because new pointer is what? Well, it's an address. So just like this picture suggests, it's a pointer pointing at a struct. So I need to not use the dot because, look, there is no n or next field in this value. I have to follow the arrow to get here. But to reveal that the syntax is actually the same, in previous lectures, how did we start at a pointer and then go there? What was the syntax for saying, here's a pointer, go there? Yeah, so star. So you know what? This arrow notation we're seeing now is actually equivalent to writing this. So this is exactly equivalent. So it's saying, here's new pointer, go there, thanks to the star notation. And once you're there, you can use the old school dot notation. So that begs the question, why the arrow? Why not just write this code like this? This is more of this syntactic sugar, right? It's the same effect. But frankly, I would claim that this is just a little more readable. In fact, it kind of mirrors our idea of pictures much more effectively than star and parentheses and dot. But these are equivalent. And the commentary here is just to reveal that they're doing nothing new. It's just a new piece of syntax. All right, so now we've initialized the null with both an n, like 5, and null. Now I'm going to do the following. So this case is easy. Suppose the list is empty. Suppose Lisa's just standing up here awkwardly. She's initialized to null, so her hands are like this. And there is no linked list, like Lisa is null. Well, this is actually the easiest case to handle because I malloc someone from the audience. I insert the number 5 into his or her n field. And then what do I do with their next field? Initialize it to null. And then what do I do with Lisa? Just point Lisa's next field, or rather point Lisa. She is a pointer at that node. So this scenario here, check for empty list, we didn't mimic this on stage, but this is by far the easiest scenario. If Lisa is not pointing at anything already, and we've just malloced a new node, there, ergo, we have a brand new linked list, just point Lisa at that node. Now, it gets a little trickier if the list belongs elsewhere. We have to do a little thinking now. Suppose that first is not null, so Lisa is actually pointing at a node. But suppose that the new node's n field is less than the first node's n field. So suppose the list has the number 5 in it, and I'm inserting the number 1. Just conceptually, to keep these things in sorted order, I need to put someone between Lisa and that first node, update Lisa to point to this new thing, number 1, and update 1 to point to 5. So how do I do this? Well, first, just notice our syntax here. I'm using my arrow notation to check those values of n. So if the new node's n is less than the first node's n, what do? Well, new pointer next. So here I can avoid temporary storage. If I am now the number 1 and I belong here, I can just steal whatever Lisa's already pointing at. So I'm the new node 1. I want to point my left hand at whatever Lisa's already pointing at. So at this point in the story, both she and I are pointing at number 5. But now who do I have to update to finish the story? I just say, Lisa, like point your left hand not at 5 anymore, point it at number 1. And so now we have an insertion at the list's head. So if we scroll down further, unfortunately, it gets a little messier. And we had the advantage before of using humans who could just kind of walk back and forth over stage. But suffice it to say that these lines of code here, in that there is a loop involved here, there is an equality test. We're checking for duplicate values now. And we're also checking whether something is less than or greater than. So here's a greater than side. Long story short, the remainder of this function is what implements all of these humans working together, where we had maybe a temporary variable. We walked down the list, looked for the right spot, inserted the node into that location, kept track of the left hands to make sure we got the ordering right. And this is definitely more complex than those first scenarios, but that's fine for now. The takeaway ultimately for today is that the basics have sunk in. Any questions on linked lists? They will recur. This is not the last time. Well, with that said, why don't we end on this slide, and we'll see you on Wednesday.